Don't echo. No echoing allowed. All right, I think we're good. So we're talking about graphing linear functions today. So if a function whose graph is a line, it's called a linear function. These are represented with linear equations. For example, y equals 2x minus 1, which is graphed to the side there.
My L looks like a boot.
Y equals 2x minus 1 is an example of a linear equation. The solution of a linear equation is any ordered pair, which ordered pairs are x, y, that makes the equation true, which basically means any point on the line. So for example, over here, like 1, 1, the point 1, 1 is on that line, so that is a solution to this equation. We can plug 1 in for x, 1 in for y, and it would be true. Yes?
I don't have this paper.
All right, another, like, say, you could also take 1.5 comma 2. Plug that in, that is a solution to this equation. Okay, so any line will make the equation true. Solutions can be written using set notation. Set notation, we don't really use it a whole lot in this class, but I want you to at least have seen it in your life. Notation. Okay, because you will see it in your book or in other math classes you take. So it looks like this. And you read this as the set of ordered pairs x, y such that, that line means such that, y equals 2x minus 1. So it basically means any x and y that makes this thing true. Okay, that's set notation. We really and truly aren't, we don't really use it, but I wanted you to see it. Okay, the value of y depends on x. So y is called the dependent variable. We kind of talked about that quickly yesterday. If y is the dependent variable, then x is the independent variable. X does what it wants and y has to deal with it and to follow along. Okay, there are different methods to graphing, but one that always works I'm going to show you. Okay, no matter how complicated it is, it will always work. And that's to, when you're given an equation, just pick some values for x, plug them in, figure out what y is. That'll give you points, and then you connect them. So to do this, let's make a lovely chart. I'm going to have 4 columns. First one will be x. The next one is where we're going to do our work and plug x in, which will give us y, which we'll put together, and we'll get our coordinate xy. Okay, and we really, for linear equations, since they're straight lines, we really just need 2 points, and then we can draw a straight line through them. So, what number could I plug in for this x that will kind of make this fraction go away? So it would make 3, right? 3 will cancel. So let's plug in 3. So y will equal 2 over 3 times 3 plus 3. And like you planned, the 3 in the numerator and denominator cancel. We're left with 2 plus 3. So what does y equal? 5, so we have a point 3, 5. So we can graph that.
I already hate this.
No, don't hate it. Oh, sorry. All right, what is another number we can plug in? 6. 6 will work. So if we plug in 6, so y equals 2 over 3 times 6 plus 3. When the 3 cancels with the 6, what's left up top? 2. So we have 2 times 2, which is 4 plus 3. So our point is 6, 7.
That's good on examples.
Alright, from that, you can use a ruler or just do your best. Make a straight line. Going down from there. Now, I want to show you that one number that it is always going to be, well, yeah, pretty much always will be an easy one to plug in is 0. Because what is anything times 0? 0. So the first whole thing cancels and y equals 3, and that shows you just another point. So that may always be a good starting point. Just plug 0 in first and then pick another number. All right, we good with that? All right, let's do the next one. So make a chart. If I need to slow down, tell me. X, we're going to plug it in to our formula. It'll give us a y, which gives us our coordinate. So what number do y'all want to plug in first?
0.
Okay, 0, and then Tanyan says 2. Okay, so we'll do those 2. Okay, so if we plug in 0, 0 plus y equals -2. What does y equal? -2. Alright, so that one's pretty quick. So we go left and right, 0, and then just go down 2.
Next one's -4.
Okay, so we plug in the next one. 2 plus y equals -2. We're trying to figure out what y equals, so let's get it by itself. So let's subtract 2 to the other side. Y equals -4 from this. And there's our point. 2, -4. Alright, you've got 2 now. Should be able to draw a straight line.
Oh, that's not gonna be mine.
So if you need help drawing straight lines, just grab your book, turn it sideways, use the edge, use a piece of paper, whatever. Alright. Word problem. I put this on there just because how much I know you love word problems.
Oh, yes.
Yes. Alright. The equation, alright, that's mathy. Write that down. Models the number of passengers on a train. Okay, so it's talking about number of passengers who can sit, okay, where x, telling us about variables, x is the number of adults, y is the number of children. And then it tells us what to do. We need to graph the equation, that's first thing. Then we need to explain what the x and y intercepts with a t, typo, sorry, represent. And then we need to describe the domain and the range. And this really looks like a lot, but it'll be okay. Okay, so first thing is to graph. So we're going to do what we just did and make a chart thing. So x, put it into our formula, 3x plus 2y equals 120. Y, it'll give us xy. 0. Okay, let's plug in 0. Let's just do that one first. One at a time.
Let's go ahead.
Okay, so 3 times 0 plus 2y equals 120. Alright, so the 3 times 0 cancels out because that's just 0. And then we'll divide by 2. So what does y equal? 60. So our point is 0, 60. I'm going to zoom into my graph and make every mark worth 10. So I'll have 10, 20, 30, 40, 50, 60, 70. I'll do the same thing on the x-axis. 10, 20, 30, 40, 50, 60, 70. We can do the negatives too if we need to.
Let's just do positive.
Alright, so I have 0, so left and right 0, up 60. Now what is that point there?
Oh, that's the y-intercept.
Hey, that's the y-intercept. We're supposed to talk about the y-intercept. So for the y-intercept, I'm just going to abbreviate and put y-int. What's going on at that point? What do our x and our y mean?
Well,
There's 60 children. I'm going to write kids, so it's shorter. And how many adults?
about 0.
0 adults. Okay, so no chaperones, just 60 crazy children. I don't imagine they'll be sitting very much. Okay. Reminds me of the Polar Express. Yes. All right. So, hey, look, we already got part of our second task done. Okay, let's pick another number to plug in. Pick something because we want to be able to make a line. So something over here. What'd you say?
I said 2, 5, something like that.
I say something a little bigger.
Okay, let's say 20. 20.
50.
45.
16.
Oh my goodness, let's just go with 50. That's a decent, easy, okay.
That's way out there.
Yeah, but we want to make an accurate line. So we're going to plug 50 in for x plus 2y equals 120. Okay, so that's 150
150.
plus 2y equals 120.
So that's like negative 30 divided by 2.
So this is interesting.
Negative.
As you said, it's negative 30. Is y, what would y end up being there?
Oh, and
Negative 15. What does y represent? Adults. Can we have negative adults? No. Okay, so
so all we gotta do is just
no negatives. No. We need to pick a different number. Let's go, what do you want to go with? Let's go little,
That's why I said
20.
25.
20. Let's go 20.
That's why I said that.
I don't like 25 because it's not on a line. That's the reason I don't like 25. Okay, so 3 times 20
That's
plus 2y equals 120. No,
60.
that's 60. So 60 plus 2y equals 120. What's 2y going to equal?
30.
Oh, that would equal 30. Y equals 30.
Well, it's going to be 60, but then you divide by 2, it would be 30.
So y equals 30. Okay, so we plugged in 20, multiplied that to get the 60 plus 2y equals 120. Minus 60 to the other side, so 2y equals 60. Then divide by 2, we get y equals 30. So that one's positive, we're good. So we get the point 20, 30. So 20, 30. And then we can draw our line. Sorry, I'm having a little trouble. Remember, it's supposed to be straight. Mine, not so much, but we see it. Okay, so we've done the first part. We've graphed it. And we've explained what the y-intercept is, but we still need to talk about the x-intercept,
Which is 40, 0.
40, 0. 40 what?
40.
Adults.
Adults.
Adult.
And 0 kids. But you know what I just realized? On this graph, do we have any negative adults or negative children? No. So the graph doesn't keep going forever. It is actually only right in those points. That is a horrible straight line.
It's okay, mine's worse.
That's a little better. So that's it for the graph.
Here's, I don't know.
Now, what we just did told us about the domain and the range. Domain, I'm just going to put D. For the domain, we're talking about X, which is what? Adults or kids?
Kids.
X is adults.
X is adults. Right? Yeah. X is adults. Do we have any negative adults? No, so we have positive numbers. What else is particular about adults?
Unless they
All
die.
numbered.
Whole numbers. We can't have any half adults or a third of an adult. Do we have the same stipulations for the kids? Yes, so kids are positive, have to be positive numbers, and
Range.
whole numbers. Yes, if you want to write that out, go for it, but obviously I like to abbreviate. Yay, we did everything.
That's ridiculous, that one problem.
I think you only have one problem like that on your homework. Okay, one more thing, and then that's my halfway point kind of. So we'll talk about that. Did the clock? No, it didn't die again. Okay, the next thing we're going to talk about is slope. Do you remember what slope is?
Oh, yeah. That's,
Okay, that's an equation that has slope in it.
that's my stuff.
What is slope?
It's the rise of the...
Rise over run. Very good. I put that one in the smaller one over there.
Yeah,
Which is the-
Next supposed to be something
That's an equation that includes it. Change in y over the change in x.
like that. Oh, yeah, I remember that.
Okay, rising, that's y, that's vertical. Run, that's x, that's horizontal. So here is the formula. And it says x2 minus x1 can't be what?
Cannot be equal.
No. What can they not equal?
They can't equal below.
They can't equal 0, right? Because they're the denominator. Denominators can't equal 0. So you're correct. They can't equal each other because that would make them equal 0.
Oh, yeah.
All right, so we're going to use that formula that we boxed in to do the problem down here. Find the slope through these 2 points. Okay, so we're going to say that y2 minus y1 over x2 minus x1. Make sure when you plug these in that you match them up, okay? So which point should we label as, well, I guess I'll just put them in order. This is 1 and this is 2. So what is y2?
6.
That's about
Minus what's y1?
2
Over, now you have to do x2, which is negative 9
minus 3.
minus 3. You got to keep them in order or else it doesn't work. So we get 4 over negative 12. Now slope, we like to keep it in a fraction.
1, negative 1/3.
Negative 1/3.
It's a lot easier if you...
Okay, so with the rest of the notes, we're going to use everything we've done together to figure out equations of lines. Okay, this little chart is like a cheat sheet. It tells you, like, whatever you're given, okay, here, it tells you, like, what to do with it. So if you're given a point and a slope, plug it into this equation. If you're given a slope and a y-intercept, plug it into this one. Okay? These have names that are so creative. The one that you put the point and the slope into, that one is called point-slope form. Yeah, okay, it's not like some crazy random name. It actually makes sense. the next one, y equals mx plus b. Y'all said this earlier. What's this one called?
Slope-intercept.
Slope-intercept, because it tells you the slope and the intercept. Now, the last one, that's when it's like completely simplified. You have x and y on one side and a number on the other. That one is called standard form. Okay, as we go through these problems, they'll give you items and then they'll tell you what form you need to end up with or whatever you need to end up with. Okay, so make sure you pay attention to that. Anytime there's an m, that is your slope. Anytime there's a b, that is your y-intercept. Actually, that's just in that one. Really, that other one should be a different b, because that's not necessarily y-intercept. Sorry. Okay. But all the m's are always slope. So let's look at this first one, example 4. Write in standard form. Okay, so we're going to end up with this one where it's got x and y on one side and a number on the other side of a line with slope -1/2 and through the point 8 -1. So it's given us a slope and a point. Which form should we plug that into?
Slope and a point?
Slope, point, slope form. Okay, so we're going to plug it in here. So the -1/2 we're going to put in for m. The 8 we're going to put in for x1. And the -1 we're going to put in for y1. In point slope form, in all of them, if it just says x or just y, you leave that in there because we need an x and a y. You replace the one that says x1, y1. So when we plug it in, we'll get y minus what's y1? -1. So we put that in parentheses so we can deal with that double negative. Equals m is -1/2 times x minus 8 for x1. From here, we will simplify and then end up with our standard form. So we'll have x on the side and y and then the number. So what's negative times negative? So we have y plus 1 equals, let's distribute, -1/2 x. What's negative times negative? Positive, and 8 divided by 2 is 4. All right, so we need to move the x from the right to the left and that 1 from the left to the right. So with that 1, we'll subtract it, right? And then the x, it's negative, so we should add it. All right, so this cancels and this cancels. X and y are not like terms, so we just write them out. So we'll have 1/2 x plus y equals 3. And that's your answer. That is standard form. Are you okay with that one? Okay. Ready for the next one? Okay, the next one, example 5, over to the right. Write in point slope form. Okay, so we're going to end up with what we started with that time. An equation of the line through 2 points. Okay, we said in order to get point slope form, we need a point. Okay, we have a point, right? It actually gave us 2. And then we need slope. How can we use 2 points to figure out slope? Yeah, so m equals y2 minus y1 over x2 minus x1. Okay, so I'm going to label so I don't get confused as to which is which. That's a 2. Sorry, it's hard to see. So what's y2? -1 minus y1, which is 5. I wrote a 1. That's wrong. See? Gets confusing. Okay, x2, just 4 minus x1, which is 1. Negative 6 over 3, so it's negative 2. So now we have slope and a point. So we just got to plug in to this point slope form. So y minus y1, I'm just going to keep my same y1, is 5 equals slope, which is negative 2, times x minus x1, which is 1. That's the answer. That's where it wanted you to get to. We got there. We can stop on that problem. Remember that as you go through your book, like you know how problems are kind of in sections? Like they're grouped together and they have like similar instructions. If you look to the side in green, it tells you an example. They correspond with this. So all the ones that say example 5 to the side, they'll be similar to this problem. Okay, so if you need help, go back to that specific problem. All right. Example 6. This one says find the slope. So we're looking for m. So we need to know what m equals. Of 4x plus 3y equals 7. What form is that starting out in? Whoa, sorry. It's starting out in standard, and then how can we get the slope? Which form can we put it into? Either one, but the one without parentheses is probably going to be easier, the slope intercept. So if we get y equals, whatever number is in front of the x will be our slope. Okay, so before we get the m, we need to get y equals. So let's get y by itself. What should we move first? Okay, and how will we move it? We're going to subtract it to the other side. Are 7 and 4x like terms? No, so we just write them out separately. So 3y equals negative 4x plus 7. Okay, variables always go in front of just numbers that don't have variables. All right, now what?
Divide 3 by 7.
We need to get rid of the 3, right?
Divide the whole thing.
So divide the whole thing by 3. Now when we divide the whole thing by 3, like that, that's the same thing. You can divide each term by 3, which gives us what we need, right? Because we need this number that's in front. So what is our slope? Negative 4 over 3. Questions on that? Did it make sense? Cody, you with us?
Me?
No, Cody.
Oh, my name's not Cody.
All right, so that's that one. We good on that? Okay. Let's look at these graphs over here. Just so we've got it all established. If there's a positive slope, the line gets bigger, so it rises from left to right, correct? If it's negative, it goes down from left to right. If the slope is 0, which that's like the floor in this room should be flat, right? It should be level, which means it has no slope, so its slope is 0, then it's a horizontal line. Now if it's vertical, that's the weird one where it's undefined. Okay, it's undefined because if you do x2 minus x1 in the denominator, it gives you a 0. Okay, I have a hard time like keeping straight in my mind which one's 0 and which one's undefined, but in the word horizontal, there's O's, right? So if it's horizontal, its slope is 0. In vertical, there are no O's, so it is undefined. I have lots of weird things like that to remember. Little things. I don't know if y'all noticed that or not. Anyways, okay, so we got positive, negative, 0, and undefined. 4 different types of slopes. Okay, now let's talk about parallel lines and perpendicular. I'm going to start with parallel. Hey, it went there. That's cool. What's the relationship between parallel lines, like their slopes?
Both the same.
Their slopes are the same. Okay, m equals m. It'll just be their intercepts that are different. Okay, if their intercepts match, then that means they're just the same line. Okay, but if their slopes will be the same, intercepts are different for parallel lines. Now for perpendicular lines, what's the relationship between slopes?
So they were 9.
They make a 90-degree angle, and what'd you say?
Slopes equal -1.
If you multiply them together, they get -1, and that works because they are negative reciprocals of each other. So if you have the slope of one line, switch the sign in front. So if it's positive, make it a negative. If it's negative, make it a positive, and then flip it for the reciprocal. Okay, so perpendicular lines, their slopes are negative reciprocals of each other. That's this last problem, and we've got 10 minutes. We can do it. Okay. Says write an equation of the line through each point, so we have 2 points, that is perpendicular to the line y equals -3/4x plus 2. Graph all 3 lines. So let's start off graphing the original one. When they're in slope-intercept form, that's the easiest ones to graph because we do what it says. So what is the intercept, y-intercept of that line? 2. So we're going to put our dot right there. And from there, what is our slope? Up 3/4. So we go up 3, right 4, and there's another point. Up 3, right 4, there's another point. We can also do the opposite. So go down 3, left 4, there's a point. Down 3, left 4, there's a point. And then you can make your line out of that. Since we're going to graph all 3 lines on this one graph, go ahead and label it. Anytime you have more than one line on a graph, label the lines so we know which is which. Okay. We graphed one of them. We're doing good. Now the other 2, what do we know about their slopes? They're perpendicular to the other one. So if the other one is 3/4, what are these slopes going to be? 4/3. Negative. -4/3. We switch the sign in front and then flip the fraction. So both of them will be -4/3. We can actually, from this point, we could go ahead and graph them, right? We know a point to start with, and then we can do the slope from there. We'll still have to come back and get the equations, but do y'all want to go ahead and graph them? Yeah. Okay, so let's start with A. So the point is 0, 4. So we just go up 4. And from there, our slope is -4/3. So down 4, right 3. Down 4, right 3, down 4, right 3. We can go the other way and go up 4, left 3. I don't have an equation for that one yet, so I'm just going to label it A. Okay, I can go ahead and do the other one as well. It's 6, 1 is the point. So right 6, up 1. And then I'm doing the same thing. Down 4, right 3. Or up 4, left 3. Remember, those 2 have the same slope, so they are parallel. But to the first line, they're perpendicular. Does it look right? That's good. All right, so last things we have to do are get the equations. This first one, the A, my black one, it's actually, we can put it straight into slope-intercept form like that, right? Because we know the slope. What's the intercept? We see it, right? What is it? 4. Yeah, because it gave us the point, actually, 0, 4. So it'll be y equals negative 4 over 3x plus 4. Okay? Now the other one, since we graphed it first, we see, and it was an exact point, we see that y-intercept, but I actually want to work it out for you for ones where like you can't see the exact y-intercept. Okay, so we have a point and a slope, so we're going to plug it into point slope form. Okay, so y minus y1, which is 1, this is y1, and this is x1, equals the slope times x minus x1, which is 6. We just need to simplify a little bit. So let's distribute the negative 4/3. So y minus 1 equals negative 4 over 3x. Negative times negative is positive 24 over 3. What's 24 over 3? 8. Okay, and then we just need to add 1 from the left side to the right side. Yes, which if you look, that should be the y-intercept on your graph. Okay. Any questions? Anything to say to our rapidly growing YouTube audience? Just kidding. It's not rapidly growing. All right then.